The morning sun cast long shadows across the Galactic Engineering Academy as students from dozens of different worlds hurried to their classes. The Academy sat on the peaceful planet of Kepler 442b, a world chosen specifically for its stable climate and safe environment. Here, the brightest minds from across the galaxy came to learn the most advanced engineering techniques known to civilization. In Classroom 7, Professor Zixtara stood at the front of the room, waiting for the last students to arrive. The professor was a magnificent sight to behold. Standing nearly 3 meters tall, their body was made of living crystal that shifted between deep blue and bright silver depending on their mood. 4 large eyes sat arranged in a diamond pattern. On their face, each one capable of seeing different types of light and energy. When Professor Zixtara spoke, their voice came through bioacoustic translators that converted their natural crystal vibrations into sounds that other species could understand. The classroom filled with an amazing variety of alien students. There was Kriana, whose 6 arms moved independently as she organized her study materials. Her species, the arachnoids, were known throughout the galaxy for their precision and attention to detail. Next to her sat Vorth, a being made entirely of swirling gases contained within a translucent environmental suit. The Nebula Collective species like Vorth were masters of atmospheric engineering and could manipulate air and gas with incredible skill. Behind them, a student from the Hive worlds clicked and buzzed as they communicated with their distant colony through quantum entanglement. The insect-like being had compound eyes that could process information at speeds that made most computers seem slow. Near the window, a reptilian student from the Desert Confederacy sat perfectly still, their scales shifting color to match the light filtering through the glass. In the very back of the classroom, almost hidden behind the much larger alien students, sat Jake Morrison. At 28 years old, Jake was the only human in the entire academy. He had earned his place through a competitive exchange program between Earth and the Galactic Coalition, a program that only accepted one human student. Every 5 years, Jake felt both honored and terrified to be there. Jake looked around at his classmates with a mixture of wonder and nervousness. Back on Earth, he had been considered brilliant. He had graduated top of his class from MIT with degrees in both civil and mechanical engineering. He had designed bridges that could withstand earthquakes, buildings that could survive hurricanes, and underground facilities that could protect people from the worst natural disasters. But here, surrounded by beings whose species had been building advanced technology for millions of years, Jake often felt like a primitive caveman trying to understand rocket science. The other students were polite to Jake, but he could sense their curiosity mixed with a subtle condescension. Humans were still considered a very young species by galactic standards. Earth had only made contact with the Galactic Coalition 50 years ago, and human technology was still centuries behind most other civilizations. Jake had overheard conversations where his classmates wondered how a human could possibly keep up with the advanced coursework. Professor Zixtara's crystals shifted to a brilliant gold color, which Jake had learned meant the professor was excited about something. The 4 eyes focused on the class and the room fell silent. "Students," Professor Zixtara began, their translated voice carrying a tone of anticipation, "today marks the culmination of your advanced survival engineering course. You have spent the past semester learning about materials science, structural dynamics, environmental adaptation, and emergency construction techniques. Now, you will put all of that knowledge to the test." The professor gestured, and a holographic display appeared in the center of the classroom. It showed a barren landscape under a dark, threatening sky. Streaks of light rained down from above, each one representing a meteor crashing into the ground with tremendous force. "Your final examination will be a practical test of your engineering skills," Professor Zixtara continued. "You will be transported to our testing facility, where you will have exactly 6 standard galactic hours to construct a shelter capable of withstanding a Class 7 meteor storm." Several students made sounds of concern in their various languages. Jake noticed that even Kriana, usually so confident, seemed worried. A Class 7 meteor storm was incredibly dangerous. The meteors in such a storm could be as large as cars and travel at speeds that would turn them into devastating weapons. Any shelter that couldn't handle such impacts would be completely destroyed. Each of you will receive identical supplies. The professor explained as the holographic display changed to show various construction materials. You will have reinforced polymer sheets, gravitational anchor bolts, atmospheric processors, energy shield generators, and basic construction tools. You must use only these materials to build your shelter. The display showed examples of the materials in detail. The polymer sheets were incredibly strong, designed to withstand extreme temperatures and impacts. The gravitational anchor bolts could secure structures to the ground with forces that defied normal physics. The atmospheric processors could create breathable air and maintain proper pressure inside a sealed space. The energy shield generators could create barriers of pure energy that could deflect some types of attacks. Jake studied each item carefully, his engineering mind already beginning to work on possible designs. He noticed that most of his classmates were doing the same thing, their various appendages moving as they took notes or made calculations on their quantum tablets. The time limit of 6 hours is intentional, Professor Zixthara added, their crystals shifting to a more serious dark blue. In a real emergency, you would not have the luxury of unlimited time. You must be able to construct effective protection quickly and efficiently. Vorth raised one of their gas-formed appendages. Professor, what are the specific parameters of the Class 7 meteor storm we will face? Excellent question, the professor replied. The meteors will range in size from 0.5 to 2.3 meters in diameter. They will impact at velocities between 15 and 45 kilometers per second. The storm will last for 1 standard hour, with an average of 12 impacts per minute across the testing area. The ground composition will be standard rocky soil with a density of 2.4 grams per cubic centimeter. Jake did quick mental calculations. Those were serious impacts, each one carrying enough energy to destroy a normal building. The testing area must be quite large if they were expecting 12 impacts per minute. But still, the danger was real. Kriana clicked her mandibles nervously. Professor, most species typically require 12 to 15 hours for such complex construction. Is 6 hours truly sufficient? Professor Zixthara's eyes gleamed with what Jake had learned to recognize as academic enthusiasm. That, my dear student, is precisely what this test is designed to determine. We will discover which species and which engineering approaches can adapt most effectively to time pressure. Jake felt a familiar sensation in his stomach, the same feeling he had experienced before every major test throughout his academic career. It was part nervousness, part excitement, and part determination. He had always performed well under pressure, but this was different. This wasn't just about getting a good grade. This was about proving that humans deserved their place among the galaxy's advanced civilizations. The professor dismissed the class, with instructions to meet at the testing facility in 1 hour. As the students filed out, Jake could hear them discussing their planned approaches in dozens of different languages. Most seemed to be focusing on variations of dome or tower structures, using the advanced materials to create elegant, efficient shelters. Jake walked slowly toward the testing facility, his mind racing through possibilities. He thought about the storms he had experienced on Earth, the tornadoes that had torn through his hometown when he was a child, the hurricanes that had battered the coast where he had worked on his first engineering project. He remembered his grandfather's stories about building storm shelters during the Dust Bowl, simple but effective structures that had saved lives when the weather turned deadly. As he reached the testing facility, Jake made a decision that would surprise everyone, including himself. While his classmates were planning to build up, Jake was going to build down. The testing facility was unlike anything Jake had ever seen. It stretched across several kilometers of carefully prepared terrain, designed to simulate the harsh conditions found on dozens of different worlds throughout the galaxy. The ground was a mixture of rocky soil and hard-packed earth, chosen specifically to represent the most common surface conditions that galactic engineers might encounter during emergency situations. Professor Zixthara led the group of students across the facility toward their designated testing zones. Each student had been assigned a square area measuring exactly 50 meters on each side. The zones were separated by energy barriers that would prevent any interference between the different construction projects. Jake could see that his zone was positioned at the far end of the testing area, somewhat isolated from the others. As they walked, Jake noticed the massive Meteor simulation equipment positioned around the perimeter of the facility. Enormous machines that looked like a cross between cannons and scientific instruments were aimed at the testing zones. These devices would create artificial meteors using compressed matter and energy fields, launching them at precisely calculated velocities to simulate the conditions of a real meteor storm. The sight of the simulation equipment made several students visibly nervous. Kriana's 6 arms moved restlessly as she calculated angles and impact forces. Vorth's gaseous form swirled more rapidly within their environmental suit, a sign that the Nebula collective being was experiencing anxiety. Even the normally calm reptilian student from the Desert Confederacy showed signs of stress, their scales shifting to darker colors. Jake felt nervous too, but it was a different kind of nervousness. While his classmates seemed worried about the technical challenge of the construction, Jake was more concerned about whether his unconventional approach would work. He had spent the walk to the facility thinking about underground construction techniques, remembering everything he had learned about excavation, soil mechanics, and subsurface engineering. When they reached the testing zones, Professor Zixthara activated a large holographic display that showed the countdown timer. The glowing numbers indicated exactly 6 hours, measured in standard galactic time units. Each student's zone was clearly marked with energy barriers that glowed softly in the air, creating visible boundaries that could not be crossed. "Students," Professor Zixthara announced, their crystalline body reflecting the morning light, "you will find your construction materials waiting in your designated zones. Remember, you must use only the materials provided. Any attempt to use outside resources will result in immediate disqualification." Jake walked to his zone and found the materials neatly arranged in the center of the area. There were stacks of polymer sheets, each one about 2 meters by 3 meters and remarkably lightweight despite their incredible strength. The gravitational anchor bolts were arranged in precise rows, each one about half a meter long and designed to secure structures against forces that would normally tear buildings apart. The atmospheric processors were compact units about the size of briefcases, capable of creating breathable air and maintaining proper pressure in enclosed spaces. The energy shield generators were slightly larger, resembling metallic boxes with complex controls on their surfaces. The basic construction tools included plasma cutters, molecular welders, gravity manipulators, and various measuring devices. Jake picked up one of the plasma cutters and examined it carefully. The device was far more advanced than anything available on Earth, capable of cutting through almost any material with incredible precision. The gravity manipulators could lift and move heavy objects with ease, while the molecular welders could join materials at the atomic level. As Jake examined his materials, he could hear the sounds of construction beginning in the other zones. The distinctive humming of energy tools filled the air, along with the various sounds that different alien species made when they were concentrating on complex tasks. Jake looked around and could see that his classmates were already beginning to assemble their shelters. Kriana had started construction of what appeared to be a dome-shaped structure. Her 6 arms moved with incredible coordination, each one performing a different task simultaneously. She was using the polymer sheets to create curved sections that would form the walls of her dome, while her other arms positioned gravitational anchor bolts and prepared the atmospheric processors. The arachnoid's approach was methodical and precise, with each component carefully measured and positioned. According to complex mathematical calculations, Vorth was taking a completely different approach. The gaseous being was using the energy shield generators to create a bubble-like structure around their construction area. The energy fields shimmered and wavered as Vorth adjusted their properties, creating what looked like a soap bubble made of pure energy. Inside the bubble, Vorth was arranging the atmospheric processors in a complex pattern that would create multiple layers of protection. The reptilian student from the Desert Confederacy was building what looked like a traditional fortress with thick walls made from multiple layers of polymer sheets. The structure was low and broad, designed to present a minimal profile to incoming meteors while providing maximum protection for anyone inside. The student worked with deliberate, careful movements, their scaled hands precise and steady. Other students were pursuing variations on similar themes. Most were building structures that extended upward from the ground, using the advanced materials to create elegant, efficient shelters that demonstrated sophisticated engineering principles. Their approaches reflected millions of years of species evolution and advanced mathematical understanding. Jake watched his classmates work for several minutes, feeling a mixture of admiration and doubt. Their constructions were impressive, showing levels of technical sophistication that far exceeded anything he had learned in his engineering courses on Earth. For a moment, he wondered if he should abandon his own plan and try to copy one of their approaches, but then Jake remembered his grandfather's stories about the great dust storms of the 1930s, when farmers had learned to build storm shelters that could protect their families from the worst weather. He thought about the tornado shelters he had seen throughout the American Midwest, simple but effective structures that had saved countless lives over the decades. He remembered the underground bunkers he had studied in his military engineering courses, structures designed to protect people from the most devastating attacks. Jake picked up one of the plasma cutters and adjusted its settings to the lowest power level. Instead of beginning construction above ground like his classmates, he walked to one corner of his zone and began cutting into the earth itself. The plasma cutter sliced through the rocky soil with ease, creating a clean, precise cut that extended downward at a slight angle. The sound of Jake's excavation was different from the construction noises coming from the other zones. Instead of the high-pitched whining of energy tools working on advanced materials, there was the deeper, more fundamental sound of earth being moved and shaped. The plasma cutter hissed quietly as it vaporized soil and rock, creating a gradually expanding hole in the ground. Several of Jake's classmates noticed his unusual approach and paused in their own work to watch. Kriana's compound eyes focused on Jake's excavation site, and she chittered something in her native language that the translators converted to a puzzled question about human construction techniques. Vorth's gaseous form swirled more rapidly as they observed Jake's work. Clearly confused by the human's approach, Professor Zixthara noticed the distraction and moved closer to Jake's zone to observe his progress. The professor's four eyes studied Jake's excavation with what appeared to be growing concern. To the crystalline being, Jake's approach seemed inefficient and potentially wasteful of precious time. "Student Morrison," Professor Zixthara called out, their translated voice carrying a tone of academic concern, "can you explain your construction approach? You appear to be expending considerable time and energy on excavation rather than utilizing the provided materials." Jake paused in his digging and looked up at the professor. His face was already showing signs of exertion, and his clothes were beginning to accumulate dust and debris from his excavation work. But his expression was confident and determined. "I'm building a foundation, Professor," Jake replied, his voice steady despite his physical effort. "Where I come from, we learn that the strongest shelters are the ones that work with the ground instead of fighting against it." The professor made notes on their evaluation tablet, clearly marking Jake's approach as unconventional and potentially problematic. From the professor's perspective, Jake was wasting valuable time on an approach that seemed primitive and inefficient compared to the sophisticated above-ground constructions being built by his classmates. Jake returned to his excavation, ignoring the curious stares and whispered comments from the other students. He continued cutting into the earth, gradually expanding his hole into a larger excavation. As he worked, he began to see how he could use the provided materials in ways that their designers had never intended. The polymer sheets, designed to form the walls and roof of above-ground structures, could be used as reinforcement for underground excavations. 3 hours had passed since the construction test began, and the testing facility was alive with the sounds of intense engineering work. The countdown timer floating above the testing area now showed exactly 3 hours remaining, its glowing numbers serving as a constant reminder of the time pressure facing all the students around the facility. The alien students had made remarkable progress on their shelter designs. Their above-ground structures were taking shape with impressive speed and sophistication, each one reflecting the unique engineering traditions of their respective species. Kriana's dome had progressed significantly since the start of the test. The arachnoid's 6 arms continued to work with perfect coordination, each one performing a different task with mechanical precision. The dome's framework was nearly complete, consisting of curved polymer sheets that had been carefully shaped and joined to create a smooth, aerodynamic surface. The structure was designed to deflect incoming meteors rather than absorb their impacts directly. Gravitational anchor bolts secured the dome to the ground at precisely calculated points, while atmospheric processors were being integrated into the walls to maintain perfect air quality inside the shelter. The dome was a masterpiece of mathematical engineering. Every curve had been calculated to distribute impact forces evenly across the entire structure. The polymer sheets were arranged in overlapping layers that would provide multiple levels of protection, while the energy shield generators were positioned to create a defensive barrier around the entire dome. Kriana's approach represented thousands of years of arachnoid engineering evolution. Combining advanced materials science with sophisticated structural analysis, Vorth's energy bubble shelter had also evolved considerably. The gaseous being had created multiple layers of energy shields, each one tuned to different frequencies and intensities. The outer layer was designed to vaporize small meteors on contact, while the inner layers would absorb and redirect the energy from larger impacts. Inside the bubble, Vorth had arranged the atmospheric processors in a complex network that would maintain perfect environmental conditions. Even if the outer shields were damaged, the Nebula Collective's approach to engineering was fundamentally different from solid-bodied species. Instead of building physical structures, they preferred to manipulate energy and matter at the molecular level. Vorth's shelter existed primarily as controlled fields of energy with only minimal physical components. The structure could adapt and reshape itself in response to different types of attacks, making it incredibly flexible and resilient. The reptilian student from the desert Confederacy had constructed what looked like a miniature fortress. The structure was built low and wide, with thick walls made from multiple layers of polymer sheets. The design was based on centuries of experience with sandstorms and extreme weather conditions on desert worlds. The fortress featured multiple chambers connected by reinforced corridors, allowing its occupants to move to different areas if one section was damaged. Energy shield generators were positioned at strategic points to create overlapping fields of protection. Other students had pursued variations on similar themes. A crystalline being from the Silicon worlds had created a structure that looked like a giant gemstone, with faceted surfaces designed to reflect meteor impacts away from the shelter. An insectoid student from the Hive worlds had built a hexagonal structure with honeycomb-like internal walls, utilizing the same architectural principles that made their species' natural habitats so incredibly strong. All of these structures were impressive examples of advanced engineering, representing the accumulated knowledge and experience of civilizations that had been building sophisticated technology for millions of years. Each design reflected careful consideration of materials science, structural dynamics, and environmental adaptation. Jake's construction zone, however, looked like a disaster area. The surface was covered with piles of excavated soil and rock, scattered tools, and what appeared to be the entrance to a large hole in the ground. To casual observers, it seemed as though the human had either given up on the assignment or had chosen an impossibly difficult approach that would never succeed in the remaining time, but Jake had not given up. Deep underground, he was working, with the focused intensity of someone who knew exactly what he was building. The excavation had expanded into a complex network of chambers and tunnels, each one carefully designed to serve a specific purpose in his underground shelter system. The main chamber was large enough to accommodate several people comfortably, with a ceiling height of nearly 3 meters. Jake had used the plasma cutter to create smooth, even walls that would distribute structural loads evenly throughout the underground space. The chamber was roughly circular, a shape that Jake knew would be naturally resistant to the compression forces that would be transmitted through the ground during meteor impacts from the main chamber. Jake had excavated several smaller rooms that would serve as backup spaces if the main area was damaged. The secondary chambers were connected by tunnels that were just large enough for a person to crawl through, but small enough to maintain structural integrity even under extreme stress. Jake had learned from studying military bunkers that redundancy was essential in any defensive structure. The entrance to Jake's bunker was carefully designed to be both hidden and secure. Instead of a simple vertical shaft, he had created an angled entrance that would be difficult for meteors to hit directly. The entrance was covered with a polymer sheet that had been camouflaged with soil and debris, making it nearly invisible from the surface. Jake had repurposed the construction materials in ways that their original designers had never imagined. The polymer sheets, intended for above-ground construction, had been cut into strips and woven together to create a flexible reinforcement matrix that lined the walls and ceiling of his underground chambers. This approach provided much more structural support than simply using the sheets as flat panels. The gravitational anchor bolts had been converted into a foundation system that distributed the weight of the surrounding earth evenly throughout the underground structure. Jake had driven the bolts deep into the bedrock beneath his excavation, creating anchor points that would prevent the bunker from collapsing even under extreme pressure. The atmospheric processors had been integrated into a ventilation system that would maintain perfect air quality throughout the underground complex. Jake had created air intake and exhaust tunnels that extended to the surface at carefully concealed locations, ensuring that the bunker would have fresh air even if the main entrance was blocked. Most impressively, Jake had figured out how to use the energy shield generators as structural reinforcement. Instead of creating external defensive barriers like his classmates, he had positioned the generators inside his underground chambers where they created localized force fields that strengthened the walls and ceiling. This approach provided incredible structural support while using minimal energy. As Jake worked in his underground chambers, the sounds of his construction were muffled by the earth above. The plasma cutter hummed quietly as he made final adjustments to the wall reinforcements. The molecular welder sealed joints in the polymer reinforcement matrix with perfect precision. The gravity manipulator moved heavy rocks and soil with ease, allowing Jake to create exactly the internal layout he wanted. Professor Zixthara had made several attempts to observe Jake's progress, but the underground nature of the construction made it difficult to evaluate from the surface. The professor had noted Jake's unusual approach in their evaluation records, marking it as either innovative or misguided depending on the final results. Student Morrison, Professor Zixthara called down into the excavation during one of their inspection visits. You have expended half of your allotted time. The structural integrity of your shelter cannot be properly evaluated until construction is complete. Are you confident that your approach will yield adequate protection? Jake's voice echoed from deep within the underground chambers, slightly muffled by the earth and polymer reinforcements, but still clearly audible. Everything's on schedule, Professor. The foundation work always takes the most time, but once that's solid, the rest goes quickly. The professor made additional notes, clearly uncertain about Jake's unconventional methodology. From their perspective, Jake's approach seemed to violate basic principles of efficient construction. Most galactic engineering focused on using advanced materials and sophisticated designs to achieve maximum protection with minimum resources. Jake's approach appeared to be the opposite, using massive amounts of manual labor to create what might be an unnecessarily complex shelter. Other students had also noticed Jake's unusual progress. During brief breaks in their own construction work, several of them had walked over to examine his excavation site. Their reactions ranged from puzzlement to concern, with most expressing doubt that any underground structure could be completed. In the remaining time, Kriana had chittered something in her native language that the translators converted to a comment about human stubbornness and inefficiency. Vorth's gaseous form had swirled with what appeared to be confusion as they tried to understand Jake's engineering logic. The reptilian student had simply stared at the excavation floor. The countdown timer showed exactly 1 hour remaining when Jake Morrison finally emerged from his underground excavation. He climbed out of what appeared to be a simple hole in the ground, his clothes covered in dirt and dust, his face streaked with sweat and grime. To anyone watching from a distance, Jake looked like someone who had spent the past 5 hours digging a very large hole and had little to show for his efforts. The contrast between Jake's appearance and the impressive structures built by his classmates was striking. Around the testing facility, magnificent shelters rose from the ground like monuments to advanced engineering. Each structure represented thousands of years of species evolution and technological development, incorporating the most sophisticated materials and design principles known to galactic civilization. Kriana had just completed the final adjustments to her dome shelter. The arachnoid's 6 arms moved with perfect coordination as she activated the energy shield generators and tested the atmospheric processors. Her dome was a masterpiece of mathematical precision, with every curve and angle calculated to provide maximum protection with minimum materials. The structure gleamed in the afternoon light, its polymer surfaces reflecting the sky like a mirror. Energy fields shimmered around the dome's perimeter, creating a protective barrier that would vaporize small meteors and deflect larger ones. Vorth's energy bubble shelter pulsed with controlled power as the gaseous being made final calibrations to the multiple layers of protective fields. The Nebula Collective's approach to engineering had created something that looked more like a soap bubble made of pure energy than a traditional building. The structure could adapt its shape and density in response to different types of attacks, making it incredibly flexible and resilient. Inside the bubble, atmospheric processors maintained perfect environmental conditions while backup systems stood ready to take over if the primary equipment was damaged. The reptilian student from the Desert Confederacy had finished their fortress-like structure, a low, broad building with thick walls and multiple internal chambers. The design was based on centuries of experience with extreme weather conditions on desert worlds, incorporating features that would protect against sandstorms, temperature extremes, and seismic activity. Energy shield generators created overlapping fields of protection around the entire structure, while redundant life support systems ensured that the shelter could function even if several components were damaged. Other students had completed equally impressive structures. The crystalline being from the Silicon worlds had created what looked like a giant gemstone with faceted surfaces that would reflect meteor impacts away from the shelter. The insectoid student from the hive worlds had built a hexagonal structure with honeycomb-like internal walls, using architectural principles that had been refined over millions of years of evolution. Each structure was a testament to the advanced engineering capabilities of its builder species. Professor Zixthara moved through the testing area, examining each completed shelter with the practiced eye of someone who had evaluated thousands of engineering projects. The professor's 4 eyes studied every detail, from the structural foundations to the energy shield configurations. Their crystalline body reflected the light from the various energy fields, creating a kaleidoscope of colors as they moved from one shelter to the next. The professor made detailed notes on their evaluation tablet, recording measurements and observations that would be used to calculate each shelter's projected survival probability. Most of the structures showed impressive engineering sophistication, with design features that demonstrated deep understanding of material science, structural dynamics, and environmental adaptation. When Professor Zixthara reached Jake's construction zone, they stopped and stared at what appeared to be a disaster area. The ground was covered with piles of excavated soil and rock. Construction tools were scattered around the area, some still showing traces of recent use. In the center of the chaos was what looked like a large hole in the ground, partially covered By polymer sheets and debris? Student Morrison, Professor Zixthara called out, their translated voice carrying a mixture of curiosity and concern. The evaluation period has concluded. Please present your completed shelter for inspection. Jake stood up from where he had been making final adjustments to his camouflaged entrance. He brushed dirt from his clothes and walked toward the professor, leaving footprints in the disturbed soil of his construction zone. Despite his disheveled appearance, Jake's expression was confident and satisfied. "Right here, Professor," Jake said, gesturing toward what appeared to be nothing more than a section of slightly disturbed ground. "The entrance is camouflaged, but the shelter is complete and ready for testing." Professor Zixthara's 4 eyes focused on the area Jake had indicated, but they could see nothing that resembled a shelter entrance. The ground looked like it had been disturbed by construction activity, but there was no obvious structure or opening visible. "I must confess, Student Morrison, that I am unable to locate your shelter entrance," the professor said, their crystals shifting to a puzzled blue-green color. "Could you provide more specific guidance?" Jake walked to a section of ground that looked identical to the surrounding area. He knelt down and carefully moved aside what appeared to be a natural accumulation of soil and debris. Beneath the camouflage, a polymer sheet became visible, and beneath that, the opening to an angled tunnel that disappeared into the earth. "The entrance is designed to be hidden," Jake explained as he revealed the opening. "On Earth, we learned that the best shelters are the ones that enemies can't find. The same principle applies to meteors." Professor Zixthara leaned forward to examine the tunnel entrance. The opening was large enough for a person to enter comfortably, but small enough to maintain structural integrity. The walls were lined with polymer reinforcement, and the tunnel angled downward at a slope that would make it difficult for meteors to hit directly. "This appears to be an underground facility," the professor observed, their tone suggesting both surprise and academic interest. Such construction techniques are rarely attempted in galactic engineering courses due to the time and labor requirements. "Would you like to inspect the interior?" Jake asked, his confidence growing as he saw the professor's genuine curiosity. "Professor." Zixthara nodded, and Jake led the way into the tunnel. The professor's crystalline body provided its own light as they descended into the underground complex, illuminating walls lined with carefully woven polymer reinforcement and ceiling supports made from repurposed gravitational anchor bolts. The tunnel opened into a main chamber that took the professor's breath away. The underground space was larger than most of the above-ground shelters, with a ceiling height of nearly 3 meters and walls that curved gently to distribute structural loads. The chamber was perfectly circular, a shape that Jake had chosen specifically for its natural resistance to compression forces. The polymer sheets had been cut into strips and woven together to create a flexible reinforcement matrix that covered every surface. This approach provided much more structural support than using the sheets as flat panels, while also allowing the walls to flex slightly under extreme pressure without breaking. The gravitational anchor bolts had been driven deep into the bedrock and connected to a framework that distributed the weight of the surrounding earth evenly throughout the structure. "This is remarkable," Professor Zixthara said, their crystals shifting to a bright gold color that indicated excitement and admiration. "The structural integrity calculations alone must have been incredibly complex." Jake shrugged with characteristic human modesty. "Actually, it's pretty straightforward, once you understand the principles. The circular shape distributes forces naturally, and the woven reinforcement prevents stress concentrations. It's the same technique we use for underground storm shelters back on Earth." The professor continued their inspection, examining the atmospheric processors that had been integrated into a ventilation system extending throughout the complex. Air intake and exhaust tunnels connected to the surface at carefully concealed locations, ensuring fresh air circulation even if the main entrance was blocked. The energy shield generators had been positioned inside the chambers where they created localized force fields that strengthened the walls and ceiling. "Student Morrison," Professor Zixthara said, their voice carrying a tone of growing respect, How did you complete such extensive construction in the allotted time? The excavation alone should have required most of your available hours. Jake led the professor through the secondary chambers and connecting tunnels, explaining his construction methodology as they walked. The key is understanding which parts of the work are actually necessary. I didn't waste time on decorative elements or complex calculations. I focused on the fundamentals, solid foundations, redundant systems, and practical protection. Each secondary chamber was designed to serve as a backup space if the main area was damaged. The connecting tunnels were sized to allow easy movement while maintaining structural integrity. Every aspect of the design reflected practical experience. With underground construction and emergency shelter systems, the professor examined the energy shield generators and discovered that Jake had used. The meteor storm simulation was scheduled to begin at exactly 6 hours after the construction test had started. Professor Zixthara gathered all the students at the observation platform, a safe distance from the testing area where they could watch the simulation without any risk of injury. The massive Meteor simulation equipment around the perimeter of the facility hummed with increasing power as the machines prepared to launch their artificial projectiles. Jake stood with his classmates on the observation platform, still covered in dirt from his underground construction work. The other students had cleaned themselves up and looked professionally prepared for the evaluation of their engineering projects. Their above-ground shelters gleamed in the late afternoon light, each one a testament to advanced galactic engineering principles. Kriana's dome shelter reflected the sky like a perfect mirror, its mathematical curves designed to deflect any incoming meteors. The energy shields around the structure pulsed with controlled power, ready to vaporize small projectiles and redirect larger ones. The arachnoid stood confidently beside her creation, her 6 arms moving in small, precise gestures as she monitored the shelter systems through her quantum tablet. Vorth's energy bubble shelter shimmered with layers of protective fields, each one tuned to different frequencies and impact types. The gaseous being's form swirled with what appeared to be satisfaction as they observed their adaptive construction. The bubble could change its shape and density in response to different attacks, making it incredibly flexible and resilient against various types of meteor impacts. The reptilian student from the Desert Confederacy watched their fortress-like structure with calm confidence. The low, broad building with its thick walls and multiple chambers had been designed based on centuries of experience with extreme weather conditions. Energy shield generators created overlapping protective fields around the entire structure, while backup systems stood ready to maintain operation. Even if primary components were damaged, other students showed similar confidence in their engineering solutions. The crystalline being's gem-like structure would reflect impacts away from the shelter. The insectoid students' hexagonal building used honeycomb architectural principles that had been refined over millions of years. Each shelter represented the accumulated knowledge and technological sophistication of advanced galactic civilizations. Professor Zixthara activated the simulation control systems, and holographic displays appeared throughout the observation area. The displays showed detailed views of each shelter, along with monitoring data that would track structural integrity, energy consumption, and survival probability throughout the test. The professor's crystalline body reflected the light from the displays as they made final preparations for the simulation. "Students," Professor Zixthara announced, their translated voice carrying formal authority, "the Class 7 Meteor storm simulation will commence in 60 seconds. The test will last for exactly 1 standard hour, during which your shelters will face meteors ranging from 0.5 to 2.3 meters in diameter, traveling at velocities between 15 and 45 kilometers per second. The countdown timer appeared on all the displays, showing the final seconds before the simulation would begin. Jake felt his heart racing as he watched the timer approach 0. Despite his confidence in his underground bunker, he knew that this test would determine whether his unconventional approach was truly superior to the sophisticated engineering of his alien classmates. The simulation began with a sound like thunder that rolled across the testing facility. The Meteor simulation equipment launched its first projectiles, creating streaks of light that crossed the sky before impacting the ground with tremendous force. The artificial meteors were indistinguishable from real ones, carrying the same kinetic energy and destructive potential. As objects that had traveled through space for millions of years, the first impacts hit the testing area with devastating effect. The ground shook with each collision, and massive explosions of dirt and debris filled the air. The Meteor simulation equipment continued firing, creating a steady rain of projectiles that fell across the entire testing facility. The sound was incredible, a continuous rumble of impacts that made normal conversation impossible. Jake watched the displays showing his classmates' shelters, hoping that their impressive engineering would protect them from the simulated storm. For the first several minutes, all the structures seemed to be performing well. The energy shields around the various shelters glowed brightly as they deflected smaller meteors, while the structural designs absorbed the shock waves from nearby impacts. Kriana's dome shelter sparkled with defensive energy as meteors struck its protective fields. The mathematical precision of the dome's design became apparent as impacts were deflected away from the structure with minimal energy loss. The arachnoid's 6 arms moved rapidly as she monitored her shelter systems, making small adjustments to maintain optimal protection. Vorth's energy bubble adapted continuously to the incoming meteors, changing its shape and density to provide maximum protection against each impact. The gaseous being's approach to engineering showed its flexibility as the bubble absorbed energy from meteors and redirected it harmlessly into the surrounding area. The reptilian student's fortress remained solid and unmoved as meteors struck its thick walls and energy shields. The low, broad design presented minimal targets for incoming projectiles, while the multiple internal chambers provided backup protection if the outer defenses were breached. But as the simulation continued and the meteor impacts became more frequent and intense, the alien shelters began to show signs of stress. The energy shields around several structures started to flicker as their power supplies became strained. The sophisticated materials and elegant designs that had seemed so impressive during construction were being pushed to their limits by the relentless bombardment. The first shelter to fail was the crystalline being's gem-like structure. Despite its beautiful faceted design, the building could not handle the accumulated stress from multiple large impacts. Cracks appeared in the crystal surfaces, and within minutes, the entire structure collapsed in a shower of glittering fragments. The monitoring display showed that the shelter's occupant would not have survived the failure. Other shelters began failing in rapid succession. The insectoid student's hexagonal building, despite its honeycomb strength, developed structural weaknesses that spread throughout the entire framework. The energy shields around several shelters overloaded and shut down, leaving the structures vulnerable to direct meteor impacts. Even the most impressive shelters were struggling. Kriana's dome began showing stress fractures as the mathematical perfection of its design encountered the chaotic reality of the meteor storm. The energy shields flickered and dimmed as the power systems became overwhelmed. Vorth's energy bubble started losing coherence as the continuous impacts exceeded its adaptive capabilities. The reptilian student's fortress held out longer than most, but eventually even its thick walls and redundant systems could not withstand the relentless bombardment. Energy shield generators overloaded, backup systems failed, and the structure began to collapse from accumulated damage. As Jake watched his classmates' shelters fail one by one, he felt a mixture of sadness and vindication. These were brilliant engineers who had created impressive structures, but their sophisticated approaches had fundamental weaknesses that became apparent under extreme stress. The monitoring displays showed that Jake's underground bunker remained completely unaffected by the meteor storm. Deep beneath the earth, the circular chamber absorbed the impact energy through the surrounding soil, while the robust construction easily withstood the transmitted shock waves. Inside the bunker, conditions remained perfectly stable, with no indication that a devastating meteor storm was raging on the surface. Above, Professor Zixthara watched the simulation results with growing amazement. The professor's 4 eyes focused on the displays showing Jake's bunker, which continued to function perfectly while every other shelter had either failed or was showing critical damage. The underground facility's structural integrity remained at 100%, with no signs of stress or failure. When the simulation finally ended after 1 full hour of continuous bombardment, the testing facility looked like a war zone. The ground was cratered and scarred from thousands of meteor impacts. The remains of the alien shelters were scattered across the testing area, their sophisticated materials and elegant designs reduced to debris and wreckage. Jake's construction zone looked almost unchanged from the surface. The camouflaged entrance to his bunker remained hidden beneath its covering of soil and debris. The piles of excavated earth had been scattered by nearby impacts, but the underground facility itself had suffered no damage whatsoever. Professor Zixthara led the group down to the testing area to examine the results firsthand. The professor's crystalline body reflected the emergency lighting as they surveyed the devastation. The other students followed in stunned silence, unable to believe that their advanced engineering had failed so completely. When they reached Jake's construction zone, the professor called down into the bunker entrance. "Student Morrison, are you prepared to exit your shelter for evaluation?" Jake's voice echoed clearly from the